Hello friends, in this chapter, we shall learn about the basics of light. Light is a familiar chapter to all of us from class 8, if we can recollect. We know that light is required for vision. That is, without light, this particular video would also seem dark to you and you would not be able to see anything around you in the absence of light. We had also learned that light is a form of energy, just as sound and wind, and that it travels at a very high speed and in straight lines called rays. Oof! There are a lot of things I know, but all these concepts shall be discussed in this video along with a lot more new concepts. So, you need to get the basics right before we begin. Basic topics that shall be covered under reflection of light are So we all know, as previously discussed, that light rays travel in straight lines and that we are able to see only when non-luminous objects reflect light and those light rays reach our eyes. We use the word reflection because light traveling in one direction gets diverted to another direction when it falls on an opaque surface. The light ray that approaches the mirror is called the incident ray, and that which is reflected is called the reflected ray. So when we look at images formed on reflective surfaces, it is a direct application of the law of reflection. The incident rays fall on the surface of the mirror only to be reflected back, forming an angle of incidence and reflection on the same plane and then reaching the eyes so that we are able to see them. This kind of reflection is called specular reflection. When we talk about reflection, we generally talk about specular reflection. The other kind of reflection is called diffuse reflection. This occurs on an uneven surface and reflected rays therefore get scattered in all directions. So when image formation takes place in a mirror, the rays converge virtually behind the mirror and the image is viewed in the mirror at a distance equal to the distance of the object from the mirror. The human eye cannot view the V path and so it sees the image in a straight line behind the mirror at a point I as shown. The reflected rays are essentially traced backwards or extrapolated backwards to find the point I. So, what are the properties of images formed on plane mirrors? Virtual and real images are different. Images formed on the other side of the mirror by imaginary convergence of light rays are called virtual images. And those formed on the same side of the mirror are called real images with real conversion of light rays. Real images are generally formed on spherical mirrors, and we shall be discussing this shortly. So here we see the difference between real and virtual images. The real image is formed on the same side of the spherical mirror. What are spherical mirrors? In physics, we define curved mirrors as spherical mirrors. If the reflecting surface is bulged inwards, it is a concave mirror. In contrast, if the reflecting surface is bulged outwards, it is called convex mirror. Convex mirror is a bulged out mirror, where the surface that is bulged out actually reflects light. It is the outer surface reflecting. This is convex or vex, that is bulging out. While concave mirrors converge rays of light, the convex mirrors actually diverge rays of light. A spherical mirror has a focal point, the point through which all straight line parallel rays pass through after reflection on the concave and convex mirror surface. If a complete circle is drawn out of the spherical surface, The point at which the center of the circle lies is called the center of curvature and is depicted by the point C. C is twice the distance from the mirror as F on a straight line from the mirror, that is referred to as the principal axis. The basic properties of reflection are guided by how rays hit the surface of the mirror and how they get reflected backwards, whether through the focal point or C or others. So we need to discuss this case by case. In both the concave and convex surfaces, rays parallel to the principal axis hit the surface of the mirror and get reflected through the focal point. In a reverse case, when incident rays pass through the focal point, they are reflected back parallel to the principal axis. The third case is where the rays pass through the center of curvature of the mirror or the center of the spherical mirror. At this point, it so happens that the rays are reflected back along the same route to pass through C again. This is true in case of both concave and convex mirrors. In the fourth and final case, we observe light rays being reflected at equal angles when they hit the pole. That is, if the incident ray forms an angle of I at point P, then the reflected ray forms another angle R equal to angle I at the point of reflection. This is again true for both concave and convex mirrors. Thanks a lot for hearing this video, and hopefully you have been able to learn the important points related to reflection of light.